All right, so let's look at some of the concepts that we are covering today. So we have geometric mean, and then we're looking at right triangles, so that means that we can be using the Pythagorean theorem, trigonometry. We could even be using special right triangles, like the 30, 60, 90, and the 45, 45, 90. So for the first one, we are finding the geometric mean between 20 and 5. So what that means is we want to set up a proportion where we have the variable x, and really it could be any variable, and then we're going to put the two numbers 20 and then 5, such that whenever we cross multiply to solve here, they're going to be multiplied together. So we use the geometric mean whenever you're solving for different parts of a triangle. So for example, let me see if I can draw a picture of one of the triangles that we've done this with before. So if we have a right triangle, and then we create another right triangle like this, and again, this is just a drawing, so it's not the best picture. But now we see that there's three triangles here. We have a small, a medium, and then the large is the original big triangle. So basically, you use the geometric mean to find the length of different sides of these by setting up proportions to solve for the missing sides. And what it ends up doing is creating a proportion like the one I wrote here in purple, where we have x over 20 is equal to 5 over x. So let's go ahead and solve. So whenever we work this out, I'm going to get 20 times 5. So let me erase this. So I'm going to get 20 times 5 is equal to x times x. Well, what is x times x? We can simplify that by making it x squared. And 20 times 5 is 100. So then if I were to solve for x, I would want to take the square root. So that gives me that x is equal to 10. And then we're going to go through the same process to solve the next one. And realize that I could set up my proportion differently, so I'm going to set it up differently just so that you can see you can do it different ways. So here I have 7 over x is equal to x over 12. But notice how whenever I do the multiplication again, we're going to be multiplying the two numbers together. So we have 12 times 7, so that gives me 84. So 84 is going to be equal to x squared. So then to solve, I'm going to take the square root on both sides. So we would get that x is the square root of 84. And you could simplify this down different ways. So we could say that if we were to create like a factor tree here, we could see that I can multiply 4 times 21 to get 84. And if I were to take the square root of 4, that since 4 is a perfect square, that gives me 2. So we could say that x is also equal to 2 multiplied by the square root of 21. And you could even plug this into your calculator. And let me show you what the decimal form would be like. So if I were to convert this into a decimal, it would be about 9.17. All right, so let's look at this next one. The next one says, label each side of the right triangle where A is the reference angle using the words opposite, adjacent, and hypotenuse. So if I'm focusing on angle A, the opposite is going to be directly across from it, the one that's not touching it. So this is going to be my opposite side. hypotenuse is always going to be opposite from the 90-degree angle. And then the adjacent would be the side that's touching, it's the line segment that's used to create angle A, but not the hypotenuse. So this is the adjacent side. Number 4 says, find the length of the hypotenuse of a right triangle with legs that measure 5 and 7. So if we wanted to, we could create a picture here. So I have a leg of 5 and 7. And if I want to solve for the hypotenuse, I would want to use the Pythagorean theorem here. So that's a squared plus b squared is equal to c squared. So we would use the legs for a and b. So 5 squared is 25 plus 7 squared is 49. So then I would want to add these together. So I get c squared is equal to 74. And then I would want to take the square root to solve for c. So you could say that c is equal to the square root of 74. If you plug that into your calculator to convert that into a decimal, it's about 8.6. All right, and then on this next one, we're asked to find the length of x. So here you can use trigonometry, but if you're familiar with the 30, 60, 90 triangle, the 30, 60, 90 special right triangle, that's going to be very helpful knowledge here. So and let me go ahead and write out, and I'm going to try to draw the picture similar to the way that we have it. Oops, that's not a very pretty. There we go. Okay, so here's my 30-degree angle. The side opposite from the 30-degree angle is our starting point of x. And then we would move on to the side opposite of the 60-degree angle. And we're going to see that that's going to be the same number x multiplied by the square root of 3. And then the hypotenuse across from the 90-degree angle can be solved by multiplying 2 times x. So if I know that I have a hypotenuse of 50, I could divide by 2. Since I know I'm multiplying by 2, I could divide by 2 to undo that multiplication to get 25. So 25 would be the side that's opposite from the 30-degree angle. So then to find this side, the one that I'm asked to solve for, all I have to do is multiply 25 times the square root of 3. So that could be your answer, or if you wanted to convert that into a decimal, that would be about 43.3. And number 6 says find the length of C. So this is another one that's similar to the one that we just did. It's a special right triangle. So if you would look up 45, 45, 90, realize that this is an isosceles right triangle. So what that means is both sides right here are equal to each other. And let me go ahead and draw a picture of the 45, 45, 90 special right triangle and the information that we know from it. So what it's saying is that the legs of this right triangle are equal to each other because they're an isosceles triangle. And then the hypotenuse can be found by multiplying the length of the side times the square root of 2. So if I know that I have a side length of 7, to solve for the hypotenuse, I would multiply 7 times the square root of 2. And that, if I want to convert that into a decimal, is very close to 9.9. All right, the next questions that we have here. So for number 7, it says find the perimeter of triangle STU. Since I'm asked to solve for one of the legs, it makes the most sense to use the Pythagorean theorem to solve this question. So we have a squared plus b squared equals c squared, with a and b being one of the legs. So I'm going to substitute the variable a for being our x in the problem. B would be the other leg that we know, which is 15, and c is our hypotenuse that we also know to be 17. So then what I would do here to solve, I know that 15 squared is 225, and 17 squared is 289. So here, to solve for x squared, I would subtract 225 from both sides. And when I do that subtraction right here, I would get the number 64. Now 64 is equal to x squared. So if I want to solve for x, x would be equal to the square root of 64. And that's a perfect square, so we get 8. So if I'm asked to find the perimeter, I'm going to add the three sides together. So 17 plus 15 plus 8. So that should give us a perimeter of 40. Number 8 says find the length of y. So what we want to do here is reference what I was going over on question number 6. This is a 45, 45, 90 triangle. So I know that these sides are going to be the same. And then the hypotenuse would just be the length of the side. I'm just writing the variable x because that's the way that we see it in our reference chart. So the variable x just represents the two legs on the triangle. Okay, so basically we know that the hypotenuse is going to be some number multiplied by the square root of 2. So if I just get rid of the square root of 2, I can figure out how long the sides would be. So we're getting that y is equal to 15, since both legs on the isosceles right triangle are going to be congruent to each other. Number 9 says find the length of x. Okay, so now for this one we will use trigonometry because we have 67 degrees and we don't already have that as a special right triangle when you have the number 67. So that's why we use trigonometry. So we have talked about, and I want to change the color now, we've talked about Soh Cah Toa. And this is a way for us to remember the trig ratios. So here, if I'm referencing the angle 67, I have the opposite side to be x, what I'm solving for, and I have the side that's opposite from the 90-degree angle. So this is my hypotenuse. So in which of these trig functions, we have sine, cosine, tangent, do we have the opposite and the hypotenuse? Right here for sine. So it would make the most sense to do sine of 67 is equal to the opposite, which is x, over our hypotenuse, which is 20. So now if I want to solve for x to eliminate the denominator and to isolate my variable, I would multiply by 20. If you plug this into your calculator, you will get, so we're going to get that this is about 18.4. And by the way, when you're plugging this into your calculator, if you're getting a different number, you want to check to make sure that your calculator is in degree mode. All right, for number 10, find the measure of the angle of elevation of the sun when a pole 25 feet tall casts a shadow 42 feet long. So here's the pole right here, 25 feet. And it's casting a shadow that is 42 feet long. Now, as you can tell, this picture is not drawn to scale, but we're just going to fill in the information that we need here. So if we're looking at the angle of elevation, we're looking at this angle right here. So I'm going to put X right here. And realize that the angle of elevation is congruent to here, the angle of depression, because they are alternate interior angles. So I know that there's different ways that you can look at the same picture. So here when I want to solve for the angle, again we have Soh Cah Toa. And if I'm looking at the angle that I'm given, I have the opposite and I have the adjacent. So which trig function would it make the most sense to use? So I have tangent of x is equal to 25 over 42. So now to solve, what I would do is I would take the inverse. So I would do tan inverse, and then in parentheses you're going to put 25 over 42. And then that's going to give you about 30.8 degrees. All right, last one's over here. Name the angle in the picture that represents the angle of depression. So here would be my angle of depression. And when you're naming an angle, you want to use three sides here. All right. Okay, sorry if I'm not sure what exactly is going to happen with my voice just now. We'll see what happens when I play the video, and maybe I can edit it out. Okay, so for number 12, it says find the length of x. So we're going to use trigonometry again here. So if we look at Soh Cah Toa, basically what we're using this for is to find out which trig function we should use, sine, cosine, or tangent. So if we're looking at angle 29, or the angle that's 29 degrees. Here, x represents the side that's adjacent, and 29 is our hypotenuse. So it makes the most sense to use the cosine function here. So we have cosine of 29 degrees is equal to adjacent, which is x, over our hypotenuse of 29. So to solve for x and isolate the variable, I'm going to multiply by 29 on both sides. And when you plug this into your calculator, you're going to get about 25.4. Okay, looking at number 13, it says find the length of x. So again, we're going to use some trigonometry here. So 12 represents the side that is opposite from the 63 degrees, and x represents our hypotenuse. So it makes the most sense to use the sine function. So we have sine of 63 is equal to the opposite of 12 over the hypotenuse. Now this one, it's going to be a little bit different to manipulate to solve. So what you can think about it as is here we have two proportions. So I'm putting sine of 63 over 1 to make it written as a fraction. So then if I were to cross multiply, I would have sine of 63 times x, and I'm going to put x in the front. Sine of 63 times x is equal to 12 times 1, which is just 12. Now to get x by itself, I would divide by sine of 63. So now what I'm seeing is really we're just replacing the denominator of x with the sine of 63 to solve. So you're going to plug that into your calculator, 12 divided by sine of 63, and that gives you about 13.8 48.5. And if I'm rounding wrong on any of these, it's because on my original document, I rounded to the hundredths place versus now I'm rounding to the tenths place, and I don't have my calculator in front of me. Number 14 says, find the measure of angle T. So here's angle T, and we're given the side that is opposite, and we are given the hypotenuse. Anytime that you're asked to find the measure of an angle, you're going to be using the inverse trig function. So sine of t is opposite over hypotenuse. So if I want to actually figure out the measure of that angle, you have to use the function where it has that -1 symbol. So when you plug that into your calculator, you're going to get about 22.9 degrees. Number 15 and 16 are different application problems with trigonometry. So number 15 says a 30-foot ladder is leaning against a building that is 15 feet tall. What is the angle of elevation that the ladder makes with the ground? So we're finding this angle right here. So I guess I could make that an X. See our right triangle right there. All right, so I have the side that's opposite, and I have the hypotenuse. So this is very similar to the one that we just solved, number 14. So I would do sine of x is equal to 15 over 30. And so then I would multiply, oops, sorry, not multiply. I'm going to use the inverse function here. And we actually see that this is equal to 30 degrees. So this is actually a 30, 60, 90 triangle. And that makes sense because if this is my x, which is opposite from the 30 degrees, then my hypotenuse would have been the 2x. So 2 times 15 gives us 30. Last one, number 16. Oh, I forgot to change the color. Oh, well, I guess it's not that important. I'll change it for number 16. All right, from the top of a 120-foot high tower, an air traffic controller observes an airplane on the runway at an angle of depression of 19 degrees. How far from the base of the tower is the airplane? So on this question, you need to be able to recognize here that the angle of depression is the same right here as the angle of elevation at the bottom. They're congruent since they're alternate interior angles. So we would put 19 there at the bottom. This side is opposite. And then the other one that we have touching it that we're asked to solve for is our adjacent. So we would want to use the tangent function. So tan of 19 is equal to opposite, which is 120, over adjacent, which is our x. So we're going to manipulate this kind of like how we did on question number 13. So we would do x is equal to 120 divided by tangent of 19. And when you plug that into your calculator, you're going to get about 348.5 feet. All right, I hope this was helpful for you guys.